Okay, so let's play the identification game. I'm going to give you 16 examples, or even some more if I think of them on the way here, of some matter. And let's practice. First of all, I have a bag of sand here. And if you look at it carefully, there are all different colors and little tiny granules. Some are a little bigger than others. So which type of matter would this be? I would suggest that for each one of these, you can turn this off, think about it, come up with the answer, and then turn it back on and get the answer. Sand is clearly a mixture. And plus, since you can see dark versus light, a little bit bigger versus smaller, it's a non-uniform mixture, no question. Our second one is a cylinder. It's made of something here. What do you think? Okay, this cylinder is actually the element aluminum. Not always easy to tell what something is, but this is the element aluminum, so you can see an element. It's pure, it's not mixed. That makes it homogeneous. Our third item is this one. Did you see it's popcorn? Popcorn, if you look at it, it has yellow gold. But the opposite end is clearly different than the other side. It's lighter in color. I don't know if you can see it on the video. I think you can. But again, you can see a very clear boundaries here. And so we're talking non-uniform mixture. It's a mixture. There's boundaries. You can see it. So it is heterogeneous. Okay, now we have to imagine that the yogurt, which is called fruit on the bottom, is in this cup. So what would this be? Well, it kind of gives you a hint. It says fruit on the bottom. So what do you need to do with this product before you eat it? You need to stir it. So we said that if you stir something, it's most likely a suspension. The fruit settles to the bottom. So it's a suspension, meaning it's a mixture, more than one thing, and you can see the difference. So it's heterogeneous. Number 5 is, again, tougher to see from there. It's coffee, and this is old coffee, so it's kind of got some mold in there. Sorry, that doesn't count. But if you look at just coffee itself, and I'm not talking coffee where you put in 5 cups of coffee, but just a teaspoon of coffee with water and some sugar, what would that be? Well, coffee, again, comes in the category, it looks like one thing. So it's either going to be a solution in this case, or a colloid, because I told you, you got coffee, you got sugar, you got water, so it's a mixture of at least 3 things. In this case, since it looks like one thing, we could shine light through it, and we find out if we diluted this a little bit, that the light you wouldn't see it, okay? So it is a solution. Number 6 is vegetable oil. What do you think this one is? Well, vegetable oil is actually from the soybean in this case. And again, if we look here, it looks like one thing. Of course, it got a cap in here, but you can see how it's clear in there. It is a compound from the soybean plant. So compound is pure, it's not mixed, and it's homogeneous. Number 7 is a very difficult one, especially looking here because you can't see the top of the molasses. This is molasses, okay? Some of these you can argue that they may be different things. Now, looking at molasses, I would say that it is a colloid, and the reason is if you look closely, you'll notice, especially at the top, it's lighter in color than below it, showing that there is some settling out, meaning it's also a mixture. There's more than one thing there, and you can see the difference. So it's heterogeneous, and it is a colloid. How about table salt? Table salt is NaCl, sodium chloride. That is 2 elements put together chemically. It is a compound. Therefore, it's pure. It's not mixed. It's actually chemically combined. That is homogeneous matter. This is another difficult one. If you look at it closely, you can see lines and you can actually see differences. Problem is, this is just the element zinc. This is a piece of zinc. So again, since it's an element, it's a pure substance, it just happens to look like this. So it is homogeneous. I told you, not all these are easy. How about paint in a can? Well, the paint in the can, we know that we have to shake the paint. We put it in a shaker. Every time we use it, that's a mixture. It's a suspension. We have to shake suspensions. Therefore, it's heterogeneous. What I got for number 11. Number 11 is another cylinder. Again, some of these aren't easy. We won't include the top. That's actually something different. This cylinder is bronze or brass, same thing. If we look at it, again here, we'd want to say it's an element or a compound, but it isn't. Bronze is a mixture. This is copper and zinc mixed together. So it is a mixture, but it looks like one thing. It's a solution. Believe it or not, a solid can be a solution. Number 12, we have cranberry juice. Cranberry juice has, if you look at the ingredients, it has cranberries in it, filtered water, has high fructose corn syrup, it's got vitamin C added. Clearly a mixture. So again, mixture, that means it's got to be one of these. If you look carefully, it's clear, or transparent at least, and it is one thing. It looks like one thing. It's homogeneous, so it must be a solution. 13 would be sugar. If we open this up, it's got sugar in it. Sugar is a compound. This is table sugar. Its chemical formula is C12H22O11. It is a compound. Therefore, it's pure. It's not a mixture. It's homogeneous. Number 14 is copper sulfate. This kind of gives it away because it's chemistry class. It is a chemical. It is copper sulfate. So we know it's got more than one element. So is it a mixture or a compound? Well, because it's a chemical, it's a compound. It's been chemically combined. Copper and the sulfur and the oxygen that are in there are actually all chemically combined as one thing. One thing, pure compound. And lastly, this is just one in your head. We have about fog or clouds or mist. You know, you're in the shower and you see the mist. Which one of these is that? Okay. Well, when we deal with fog and cloud, what you don't know, and maybe you've seen this at night, they'll have those big spotlights sometime that'll shine, and you can actually see the beam in the air, it seems like. That automatically makes it a colloid. So fog and clouds and mist are all colloids. That means they are mixtures, and they are different. They have different phases in them, boundaries. And I would say one more, you have to be careful. Milk is a good example. What's milk? If you go to the store, the milk carton says homogenized milk. Homogenized. But it's not. They have to actually make it homogeneous because milk is actually a colloid. It's got fat and water and other things mixed together, so it's a mixture. And if you let milk set long enough, it'll start to settle out a little bit, meaning it's heterogeneous. And in this case, it would be a colloid because it doesn't settle out very quickly. Its molecules are pretty small.